All right, let's get started here. Let me move this over here so you can hear me. So sorry about the rough start to this. So let's talk about this new unit we're kind of on, and it's not really new. We're talking about quadratic functions, and you know what quadratic functions are. You've been dealing with quadratic functions, and quadratic is basically a way of somebody referring to anything that has an x squared term. So something to the power of 2, where that is that's your highest degree of your equation. So a quadratic function, generally speaking, has a shape that looks like a parabola, right? And we're going to talk about that. But it's something where if you've got something set up here, typical quadratic function will look kind of like that, and it will have arrows going off in both ways. And we're going to look at these, all right? And we're going to talk about, them opening upward, downward, vertex. We're going to talk about a lot of different things with this. So in order to do that, we need to go over some kind of vocabulary here and understand that you guys know what we're talking about. So what I figured we do is let's graph f of x equals x squared. So let's just put that out. And so I'll show you in the next video formally how to do this. But we have I suppose if I could write cleanly, this would go a lot easier. Say we have x here and we have f of x here, which is another way of saying y. All right, f of x is y. So for x, let's just put in some numbers. So if we put 0 in, all right, I know 0 squared is 0. All right, if I put 1 in, 1 squared is 1. If I put 2 in, 2 squared is 4. If I put 3 in, 3 squared is 9. And all I'm doing is just putting the number in right there. And if I do some negative numbers, I'm going to get the same kind of values, because when you square a negative number, it makes it positive. So negative 2 and negative 3 are basically going to be the same thing what you got before. So what you get when you graph this is you get something that starts there, goes there, you get one up here, and I don't have a great stylus, so you'll have to, forgive how kind of rough this is. Now it's not wanting to, so it kind of goes up there, and then it'll sort of go up this way like that. That side looks a little better. All right, so this is basically the graph we're looking at for f of x equals x squared. So there's a few points we got to talk about on here. First of all, like we said, this is called a parabola. And a parabola is basically another way of saying it's basically a bell shape. All right, that's what a parabola is. Now, every parabola that's set up like this has something called an axis of symmetry. And what an axis of symmetry is anything is a line that goes through the parabola, all right? And in this case, it goes right there, where if you could kind of like cut the parabola and fold it over, like kind of over on the axis like this, it would lay on top of itself. So, and think about what symmetry is. It's a reflection. It's the line of reflection for the parabola. All right? So, and then on the axis of symmetry, and this is really important that I set it that way, so on the axis of symmetry, we have this thing called the vertex. And the vertex is the point, and it's either the minimum or the maximum point of the graph, and I'll talk a little bit more about that in a second. It's the highest or the lowest point of the graph. It'll be one or the other. It can't be both. And it is basically where the graph turns, where it turns and it goes the other direction. And so we call that point the vertex because, like I said, it's either the highest or the lowest point. All right? And the vertex lies on the axis of symmetry. So that's kind of important. And then you have these two terms, maximum and minimum. So these parabolas are going to have either a minimum point or they're going to have a maximum point. So if you look at this one right here, this one does not have a maximum because both of these, and I'm going to go back to using like yellow here. Both of these kind of go off to positive and negative. They both go off to positive infinity in the y direction, right? But they do have a minimum, right? And the minimum, the lowest point they ever get to is right here. And I didn't do a good job of drawing that. But the lowest point they get to is 0, right? So 0 would be the minimum. And the minimum or maximum is always the vertex. It's always the vertex with these, all right? That's what's kind of nice about these is there's some slightly different names, but they're all sort of related to each other. All right, and then domain is your x values and range is your y values. And when you look at the domain of most of these, your domain is almost always going to be, so it, or they would write it, they would say D, and they would say that, and then they'd usually do something like this, which say x, and then it's all real numbers, or another way they'll write it, and that you'll see in the book, and I need a little bit of room to do this, but they'll use a negative infinity sign, and they'll say x and positive. And so this is a way of saying basically it's you know, the domain is infinite, right? Okay, x values go all the way this way and all the way this way. Okay, for the range, the ranges on these are usually going to be restricted. Okay, so the range is usually going to like be from 1 point to positive infinity or from 1 point to negative infinity. And so when you look at this case right here, and I'm going to write that up here, my range is going to be the set where y, for y is always going to be greater than or equal to 0. Okay, so you would put y, you put your line, and then you would say, you know, 0. Or actually, let's write this way. Having a lot of problems with this today. So y is greater than or equal to 0. And then that's your range. All right. So these are kind of the formal ways of writing that out. Just I think understanding it is the big thing, so that when you're seeing these terms, you're not getting completely confused about it. So let's look at one more real quick, and let's just pick out our high points. So I purposely picked another one here. So this is negative 1/2 x squared. So let's make our x and our y chart. Remember, y is another way of saying f of x. Okay, so for x, let's put in 0. If I put 0 in, that gives me 0. If I put 1 in, that 1 squared times negative 1/2 is going to give me negative 1/2. All right. If I put negative 1 in, it's going to give me the same exact thing. If I put 2 in, 2 squared is 4. So then you would have 4 times 1/2, which is 2, and it would be negative 2. And then negative 2 would also return a value of negative 2. So I'm going to get this parabola, right, that starts here, all right? That's my 0, 0 point. And I have 1, negative 1/2, which gives me a point kind of there. I have 2, negative 2. And so you're going to get this matching thing that opens up a lot more slowly than the other one. But it's still a parabola, right? And now let's identify our features really quick. Well, our axis of symmetry, right? I don't like that dark green. Let's go with this. This is going to be our axis of symmetry. Is going to be right here. Okay, so that's the thing that sort of splits the parabola in half. So that's our axis of symmetry, where we have our a reflection of it. Our vertex is right there. So our vertex is right there, and that's the point 0, 0. And then we could say that the vertex is also our maximum of this one. We don't have a minimum of this one because this thing keeps going down, right? So when you think you've gone as low as you can go lower. All right, so the vertex, maximum. All right, next, if we think of the other terms we have our domain and our range. Okay, so our domain, all right, I'm going to change colors here. This isn't looking as neat as I'd like it. Our domain is basically x is all the values from negative infinity, and I'm running out of room here, of course, to positive infinity. So that's my domain. And then our range is basically y is going to be anything that is equal to 0 or less. It never gets above 0. So the way I would write that is I would say y, and then I would say if you have 0 or negative infinity right here, or no, what am I doing? I'm really confused. I apologize about that. You would say that y is less than or equal to 0. All right? And you could also write it basically as being bound by 0 and negative infinity, kind of the way we bound x up here. So that's these are our features of our graph. It's good to just kind of know what the terminology is, because when you're doing your ALEKS problems on this, they're gonna ask you about that and using that kind of language. So I wanted to make sure we were very clear on all of that. So thanks for listening.